All right, so we're gonna go ahead and get started. Welcome to our second meetup of the month. Happy to have you all here. I don't have any housekeeping to talk about, so I'm just gonna go ahead and hand it over to Jake so that you all can have your night back as soon as we're done and you ask all the questions you want to ask. Jake is one of my coworkers, really smart developer and always learning something new. And so he's been learning GraphQL, and he's going to tell us about building APIs and microservices with it. And I'm going to go ahead and hand it over to him. Go ahead, Jake.
Awesome. Thank you. So a lot of people have probably heard of GraphQL. It's kind of, you know, in this world of development, things are always coming out. There's always new frameworks. You know, so it kind of takes time for some to catch on, like design practices or new libraries. You know, so it's kind of tough to figure out the ones that are going to do well and the ones that aren't. And a good way to look at that is how they kind of interact with like modern architecture, right? So GraphQL is a great, you know, service library concept. We'll get into that a little bit more because there's a lot of confusion around it. But it's a really, really powerful tool once you can kind of grasp, you know, the concepts that it uses and how it's powerful, because then you can do some really, really amazing things with it. So we will get on with the presentation. So hi, I'm Jake from Addigy. I've been working at Addigy for about 4 years now. On the side, I've done some teaching at the University of Miami. I've done a couple of workshops for hackathons and shell hacks. You know, I try to stay up to date with the most recent technology and kind of, you know, design practices, new architecture services, that kind of stuff to try and keep up to date. And GraphQL is kind of like my most recent venture because I've heard about it a lot. I know a lot of people are using it, but I don't know a whole lot about it. So I figured I'd start learning on it a little bit more. I was wondering if anybody was going to get that. Christina actually didn't get this joke in the beginning. I was a little hurt. All right, so we'll kind of preface the future of like software development a little bit. So in the future, so in the future, developers will only be concerned with the business layer of an application, and semantics are not going to be needed anymore. So that was kind of put forth by Amazon. And what that kind of means is, you know, looking at old school design practices, you know, there was a lot of semantics into building an application, you know, because in order to build up an enterprise level API service, there's a lot of stuff that you have to be concerned about that is kind of separate from the meat of what the project is made for, right? So what that kind of means is, you know, when you have a service, you really only define what that service is going to be doing in the business layer, the business logic, right? You have the API handler layer, you have the data layer, and then you have the network layer, and like, you know, a couple of more. So as code kind of evolves and gets more automated with the new services that are coming out, these different layers of an application are starting to become more and more automated in a way that you will be concerned a lot less on how, you know, your database interaction goes or how your handler is handling authentication and, you know, that kind of thing, to the point where you just need to write a couple of configuration options and just write the business logic, and that's all you need to get an API going. You know, so that's kind of where GraphQL ends up going. So what is GraphQL, right? Everybody's heard about it. Everybody knows about it, but it's kind of like this elusive, like Batman figure, you know, nobody knows what it does. They just heard that it's like kind of powerful, I guess, right? But is it a library? Is it a service? Is it a language? Well, actually, it's a design concept, and it's wrapped in a couple of different clients. So you could essentially take the concepts of GraphQL, and that's kind of what we've done at Addigy a little bit. You can abstract away the concept of how it works as like an overview, and still get a bunch of the benefits. GraphQL just encompasses a pretty standardized way that is kind of widely accepted on enterprise applications on the best way to build an API. So they kind of automate all of the small things. So we'll kind of go into what that means. So from a low level on the actual implementation of a GraphQL API, you first start off with a schema, right? Like all applications, you start off with your objects. But instead of defining the objects that you later use in your application, you define this in the API layer. So when you define your fields and your values, this exclamation point is kind of like a null pointer, which means it's optional. So it's an optional parameter. When you define your schema, then you can start defining your methods for your API. So these would be queries and mutations. And how GraphQL kind of handles this is they split off every functionality that your endpoint could possibly have into a query or a mutation. So every single CRUD operation, every API endpoint that you're going to do is going to fall into one of these two categories. So you kind of separate the functionality between the two, so you can kind of better handle validation, input, all that kind of stuff. So with the query, when you want to define a specific method, we'll say in this example, we want a method to get books, right? I should back up and say these are not going to be multiple endpoints. How GraphQL encompasses all of this functionality is actually within a single endpoint that you pass a query string for, and you kind of interact with the API through that one endpoint through the query string. And I'll have some examples of that in a second. So let's say we talk to our GraphQL API and we want to get some books. Let's say we're making a library application. In order to do that, we define the method name for the query, and then we give it a return field, right? So if we want an array of books, we just pass in its square brackets and say it's the book type, the book schema. So that way GraphQL can automatically validate the output value. And in turn, that helps your front end client, because you will always be confident that you're going to be getting some book array back. It might be empty, but you will always get an array, which makes it a lot easier to do certain error handling and parsing and all of that. But let's say we want to pass in a parameter, right? We want to get a book by title. Well, we slap some parentheses on it. We say this is the title parameter, and this is of type string, and this will return back a book. Okay, so now when I go to make my method, or when I go to query the API, I just pass in my title, and I know I will be getting back a book. The nice thing is, if I try to, this does the input validation automatically. So if I try to pass in a number or a Boolean, then it will throw me an error as soon as it hits the handler level, instead of going through the different layers of an application before it finally returns back that error saying this is an invalid type. So that saves you a lot of processing. It saves you a lot of time. And we'll get into how much time and processing that actually saves you in a little bit. Mutations, they follow the exact same standard. This is just a little bit more advanced because now we're passing in a book object. And we say there will always be a book object here, because if we're passing a book to create, we want to make sure that it's not going to be empty. We want to make sure all the fields are there. We can do that by saying, exclamation point. We can update a book. And what happens now is, once we define our standard methods, right? Get books by title, we can now define our resolvers. So what these resolvers do is the actual logic for that method. Okay, so this is where you define the actual logic for that method. Get books is pretty straightforward. We just want to return the books. So this is using a mock data layer So we can just return back the books that we're just hard coding in our application. If we want to do get books by title, we can mock the logic for that, find ourselves, and just return back the book. So these resolvers are where you would attach your business logic or data layer logic, right? So that way, when you have the request coming in, it goes straight through the method, validates, and then hits that resolver. Thought the exclamation point cannot be null. Yeah. I have it backwards. This code isn't updated. So moving on to making a request, this is the query string that we were talking about. So in order to make a GraphQL request, you have to have a GraphQL client, and you pass this in as your string for a query. It does look a little bit different than how you would normally, call methods. This is the learning curve part. But the nice thing is GraphQL makes the documentation really easy, so you can kind of follow this standard and get your wheels rolling a little bit faster. So the syntax is first followed off by the action that you want to take, followed by the method. If you don't have any input parameters, you just leave you just put the method name and you leave everything else empty. If you do have some input, then you put that in right in the parentheses right after the method name. And then in the carets, you actually have to define what fields you want to get back. And GraphQL will actually project. So this is actually, for those that don't know, this is called projecting. So if you were to project from a database and say, I only want title and author, the database would only give you those fields. So GraphQL implements that functionality automatically. So if I wanted to remove some of these, then it would get removed from all requests. By standard, I don't have to do anything else. I don't have to make any more endpoints for that. So how fast would that be, right? So because the API handler layer is now completely automated by configuration options, there's actually very, very little processing that needs to be done in order to handle the initial, parsing of the request, handling of the validation, error handling if there is any. And that translates to much, much faster response times between a standard REST API and a GraphQL API. So, the average here is around, 43-ish% faster as a response execution time, just based off of, the request hitting the server and coming back. So you can imagine if you start to scale like crazy and you're using Lambda functions or cloud functions, or some kind of cloud processing where you have to pay per, nanosecond of processing time, this is going to save you a lot of money because now you're cutting your response time by a lot. So in the beginning, when, we were talking about Instagram or Amazon, they have to shave down their response time, by 10 milliseconds would save them millions of dollars. GraphQL is an obvious choice because for every API that implements this, is now going to save them a ton of money, right? Now, from a high level, how would this be used, right? So you would have your client applications, that'd be your web app, mobile app, and your other services. And you could wrap your entire application into an API gateway, right? So for those of you that are familiar with AWS API Gateway, that uses a lot of GraphQL. So this gives you a standard way of passing, because remember, in that resolver logic, we don't have to specify a data store method or a mock data store logic. We could absolutely just make a request to another service and say, hey, I want books, and then just return that back through the API gateway. So now we start to create a standard centralized API that we can have passed to a bunch of different services, or they can go directly to collections. And that gives us some really nice options because that means we can start doing authentication as a standard. We can do GraphQL. They have built-in authentication methods. So you just define your middleware and the permissions that it needs, and it can assign that to every single endpoint that is required. So again, you're programming this by configuration with very, very little code, which makes it much, much easier to maintain, makes it much faster, and much more reliable. So this works really well when you're communicating with a lot of other services in a microservice architecture. One cool thing to note about GraphQL is they actually have some options where you can specify an authentication role for specific fields in a schema as well. So, let's say you have, a book and you don't want people to be able to see if it's available, if they have a certain role. So you can attach that directive on, and it will remove that if they don't hit that authentication role, which is really, really cool. So what are the benefits of this, right? We've already gone through it a little bit. It eliminates the needs for handlers entirely, right? Because now you don't need to write any handlers. It's all just configuration. It's strongly typed, which makes it very, very easy to, it takes all the guesswork around an API. It's insanely fast to develop. Making new endpoints is, a fraction of the time, as well, assuming that you're handling an endpoint like you should in a production environment with validation, error handling, all of that. It handles almost all the logic for validation functions, and you get access to GraphQL's baked-in features. And this is some insane stuff right here. The projecting request we talked about, authentication and security. It is self-documenting. So when you want to do an export, it documents your entire API in a very, very nice format. And I'll show you that in a little bit. You can do schema stitching between different collections. You can take two objects and stitch them together. You get access to the playground, so you can do easy API testing, as well as a bunch more features. So this translates to less semantics, and you only write business logic, because everything else is taken care of you. All this really cares about is what are you actually doing in the code. So now on to the advanced stuff. Subscriptions. Okay, this is one of the biggest things with GraphQL. They have a built-in RTM functionality, right? So, for the people who know what RTM is, it's real-time messaging, and it's a way to, send the data to your front end so it's actually reactive and it keeps up to date. So now that you have broken up your API into queries and mutations, there's a third set that sits right in the middle for subscriptions. So your GraphQL client on the front end connects to your GraphQL subscription service, depending on the method that you use. And anytime one of those objects gets updated, it'll automatically send back the message to the GraphQL client on the front end and update whatever UI you have, right? So now, as you start to handle your read and your writes, anytime you detect a write, you can send that back to the front end and say, hey, everybody, this just happened, which is amazing functionality. That starts to lead us to CQRS and event sourcing. So some of you may have heard about this. Some might not have. This is a little more advanced topic for microservice architecture, but essentially what CQRS is a valid way to handle event sourcing. And event sourcing essentially is having a microservice with its data store, but only having the data store per microservice and keeping an event log for each data store, right? So now what happens is, since every microservice has its event store locally, they can start to use subscriptions or just any kind of like update or event bus, that they like. And they can start to keep a log of all the transactions in their databases. They can start emitting events to other applications, which is, much better as you start to move towards event-based microservices. And GraphQL is an amazing client to be able to use to implement event sourcing, because historically speaking, event sourcing has been really, really powerful, but kind of difficult to implement and handle, like certain errors and messaging. It can get a little tangled, but GraphQL makes it insanely easy to implement something as advanced as event sourcing, which is incredible, right? So that moves on to our use case number one, right? Microservice communication. now that the entirety of the modern world is starting to move to microservices, there are some problems that are coming with that, right? And part of that is how to communicate these microservices. The initial thought is, I'm just going to use the API, right? Like that's how everybody does it. That's how I've always done it. But that starts to cause a lot of problems because you start to have microservices depend on other microservices. And as they start to ping pong around your ecosystem to get the information that it needs, it becomes really long response times. The error handling is really difficult. If a microservice goes down, it's going to cascade through the entire platform. There's a lot of problems with having an API only communication layer for your microservices. And that's where event sourcing and event-driven microservices comes in. And GraphQL makes it very, very easy and very straightforward to implement something like an event bus or event sourcing to be able to communicate between these microservices. So now if we have a books microservice and a library microservice, whenever this book microservices says there's a new book, it's going to publish it to its book stream. And since the library microservice already has a subscription to the book microservice, it'll send a subscription message back to the library, and it can update all of its nodes in the cluster, or send it out elsewhere that is listening to it. So now we can start to have some real-time communication between microservices, not just real-time communication with the front end, you know? And that's kind of the problem when you want to use real-time management with microservices. You need some kind of way to do this, and GraphQL is an amazing way to do that. Use case number 2, we've already talked about it a little bit. RTM API Gateway, it's freaking awesome. You know, you have a centralized API client that has actually insanely small code, really, really small amounts of code compared to like what it's servicing. And everything is just defined through configuration options. So now that compared with it's fast, it's really reliable, its validation is amazing, and its error handling is really good. That takes off so much load from all the other microservices that when you actually go to develop one of these microservices, most of the hard work is already done for you. You don't have to worry about authentication and input validation and blah, 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 because GraphQL did that for you, because it has all that configuration option already stored. And this becomes really, really powerful when you start to scale to hundreds or thousands of microservices or tens of thousands of endpoints. And there's one startup out there that I saw a talk on where their entire business model is an API as a service. And they have tens of thousands of API endpoints. And they actually just use a single GraphQL client, and they've set it up in a way to where they don't even need to define anything in the code. It's all JSON based or YAML based. They just define all of their schemas and all their endpoints, validation, everything in a YAML file, and every endpoint is a YAML file. So now they just created an entire API gateway with literally no code. It's incredible. That's what sets them apart from the rest, and that's why they're an API as a service. It's pretty amazing. So now that we've kind of talked about the benefits of it, right? Who actually uses this? Does anybody big actually use it? Because that's the real testament of like, is this going to be here to stay, or is this just another fancy framework that's going to get thrown out in like a couple of years? So there's actually a lot of people that use this, some really heavy hitters. And, you know, if all of these people use it, then that means that there's probably something there that the majority of people aren't seeing yet. And that's kind of like the direction that we want to go in, you know, with our applications or our services. We want to follow what these guys are doing because they are the pioneers of modern architecture, right? And if we don't keep up and we don't see what they're doing, then you'll get left behind. And, you know, someone else that is following modern architecture is going to have a much easier time, you know, and it's all about making it easier. So that's it for the slides. And now we will jump into the actual code itself. So this is everything that I used from the slides, right? So we just have a hard-coded books store. This is just some mock data. We define our book type. we define our input type and our update type. We have a query and mutations that we define our methods for. And then down here in our resolvers, we actually implement that resolver logic. And then we initialize that in the Apollo server. And then we just listen for that. And that spins up. Let me see if the server is running. Whoops. It is. Okay. So you can see this application was set up with super, super small amounts of code. And if I wanted to create a new method, it would make it very, very easy. So let's say I wanted to add another method to get books by an author, because we have get books and books by title, but we don't have something by author. So all I have to do is really just duplicate this, change the name, change that as well, author. That'll give me back a book. I'll copy this name, drop it down here. It's the same logic. Put the title, and then we just change the arguments to author, and bam, there's my new endpoint, get books by author. You know, that was done really, really fast. It has all the same input validation that get books by title does, so I know it's consistent. It's going to be reliable because I know if the request actually makes it to this point, then it's past the validation, and I can actually just worry about the actual logic in itself. So this is where you would want to pass, you know, to a database if you wanted to, or to another API, or some kind of other service if you want. And a lot of modern databases actually have a built-in GraphQL API that you can interact with. So like Mongo, for example, you can interact with your Mongo database through GraphQL. So by defining some like middleware logic to handle authentication, maybe a little bit of security, you could absolutely just bypass the backend completely from the front end and just go straight from your front end to the database. You know, in any other circumstance, that would be a really bad thing to do. But as long as you're handling like the bulk of what you need to in terms of like security and authentication, you know, that might be good in some cases. So now if we go over to how to make an actual request, this is the playground that was mentioned in the presentation, right? So we have our, let me see if I can make this bigger actually. Beautiful. We have our action, which is saying we want to do a query. We have our method, we say we want to get books. And then we have our fields that we want to get back. So when I run this, this is the data that I get back. This is all my books that I have hard-coded. Now, let's say this list is actually 10,000 books long, and my front end is way too slow because this is putting out too much data, right? I could paginate this absolutely no problem using GraphQL. I don't have an example set up for that, but GraphQL does have a cursor-based management system for paginating requests. But you know, part of that is you only want the fields returned to the front end that you're going to be using. You don't want some big fields that are taking up a lot of data that you don't want on the front end because, you know, it's taking up bandwidth, it's making it slower. And you don't really want to go into the back end and make a new endpoint just to like say it's books except without the title. You know, that can get kind of annoying. So if I just want to see everything from the author that's available, I can just remove that title field. And when I make this request, it just removes it at the API layer. So I don't have to change any endpoint logic. I don't have to change any database logic. It just happens. So here's an example of how to get the book by title. We pass in a title name. This is The Awakening. We have title, author, and available. When we send that, we get our book back. And again, I can just make a request. I just want to say, is this book available? And yes, it is. It's available. So super, super lightweight requests and really, really quick. And here's how a mutation looks like. So I have my title, my author, is it available? And then I just pass in the book type and I say, you know, these are the fields that I want. I make it. And then I come back and say, let me grab this title real quick. How to GraphQL. Whoops, I only have, let's put title and author. And there we go. I got my book back. Now, let's say, I get rid of everything and I'm thinking, I don't know what's contained in this API. I don't want to have to open up the project, or I don't want to have to clone the project to see what kind of objects it uses or what kind of methods the API uses. Well, that's one of the amazing built-in benefits of GraphQL is if I come over here to this schema, it gives me everything that this GraphQL is allowing me to do. And I can even download this and use it for my own self. It gives me all the methods, their types, the type definitions, as well as the input types. But let's say I wanted to make this available for public use. This is a public API now, right? Well, I can just click this little tab and say docs. And now I get a nice UI breaking up this API into a readable format. So I see I have the get books option, I have the get books by title option, create book, update book. And when I click through, I can see this takes in a title of string and returns back a book. What does that book type look like? It looks like this. And what kind of arguments it takes that, So it's a super, super easy way. And you can export this. So now you can push this to any kind of blog post or your GitHub repo to make the documentation process really, really easy. So with that being said, with the demo done and the code shown, that's it for my presentation. Thank you guys for listening. Do we have any questions? That was a lot of information, so I'm sure someone's got some questions. Oh, does that mean I covered everything on my first try? I covered everything possible that GraphQL can offer. How do you do pagination? So in GraphQL, when you do the pagination, you can do it a couple of ways. So you can either paginate through the database itself. That's pretty standard. And you take that from the cursor and you send that back. That's if you don't want your application holding all of that data, right? Which sometimes you do, sometimes you don't. If you want to paginate it through GraphQL specifically, you can use a couple of directives. They have options in the type. So let me see if I can come back here. In these type options right here, they have a couple of built-in parameters. So instead of having like Boolean here, I can put some kind of directive saying that this is going to be a cursor. So when I return back a list of if we have 10,000 books and I return back to the GraphQL, it'll store that. And when you hit the same endpoint with its cursor, it'll go over to the next set of data, and it can hold that for X amount of time or so forth. Is there a specific way to handle status codes on the front end? So here, I'll show you what a failed request looks like. So let's see, we'll go over to get books and I'll just say we're passing in something wrong here. Oh, whoops. Get book by title. And we'll just pass in 0. So this will be a validation error, right? So what happens is it throws back a 400, I think, if I believe. And the error message is actually just stored in a nice little JSON object like this. So when you handle the status code, it's a single status code, if I remember. And the entire GraphQL error handling just gets sent back to you. So you can start handling this error on your own on the front end. So this gives you a lot of information. So the message, where this actually happened, the traceback. Let's see, message about it, more location. This just gives you a bunch of information about that. Any more questions? If you are starting a new API service, I would almost always want to go with GraphQL. So really the difference between when you would choose GraphQL versus a REST API is GraphQL does have a learning curve. It's not super widely known yet. So if you go the choice of actually implementing a GraphQL API, you are going to have to, run that learning curve, and it might be a little slower at first because it is a brand new way of handling requests. But other than that, there's not really a whole lot of option for going for REST over GraphQL at this point. This is kind of like the next step in modern API. The only problem is just having it widely picked up, because this is very, very different than any other request design standard that's out there right now. So you're kind of, you might have trouble finding people that know it, or you might have trouble learning some of the small stuff because it can be a little complex to do a little bit more complicated logic in there. That's why I say there is a learning curve to it. But once you really pick up, the small things, how to interact with certain directives or how to interact with certain like schema stitching, that's when it becomes really, really powerful, because you're starting to reach past the level of customization with REST. It's just going to take some time to get there because you actually have to like really learn about it. REST is just kind of default. Everybody knows it. You just put whatever logic you want to have in there. With GraphQL, it's a little different. What about debugging? So yeah, I mean, that's a fantastic point. I mean, luckily, since GraphQL does give you a pretty good error message and traceback errors, it makes it a lot easier to be able to debug problems in the actual handler abstraction layer. It might not be as well. I would say they'd probably be about the same, because if you had a stack trace thrown in your REST API or an error thrown, when you get that error back and you want to go through and actually debug it, usually you copy that error, you look for where that's being thrown, or you check the stack trace, you check where that's being thrown. So this does the same thing, except this does it on its own. So I would imagine that they'd be pretty much the same. That's a great question, by the way. It was really good. Cool. Yeah, I mean, I guess, can the subscription feature replace a messaging queue broker? Yes. Yeah, it can. Because the subscription is actually handled. So here, let me go back to the code over here. So how we have these queries and these mutations, if you wanted to create a subscription, you would create a third one of these, right? So when you actually have a subscription, you want to use a queue, you would implement that logic on your own. So it's not like GraphQL, handles like the messaging type and everything on its own. It only handles the communication. If you want to actually use like a queue, you could implement that on your own and still send that back to the front end. But this essentially just replaces like some kind of RTM broker, so this handles the WebSocket connection. It does all that on its own. You're very welcome. Will your slides be available somewhere? Yeah. I mean, if I don't know what the best way to get that out there is. Is there like a log in Miami.js that I could put these slides, like a library? No pun intended.
There's probably some online service where you could share it. I'll look into it and let you know. And how about
no
how about
problem.
the sample app? Will this be available on like GitHub or something?
Yeah, no problem.
Will this be available on like GitHub or something? How about the sample app? Will this be available on like GitHub or something? Yeah, no problem. 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 Yeah,
Yeah, I can make this available on GitHub. Yeah, absolutely.
All right. If anyone has any other questions, you can unmute yourself or just drop it in.
Thanks, George. Cool. All right. Any last questions or forever hold your peace? Great presentation. Awesome. Thank you very much, everybody. I'm glad you liked it. I hope you guys learned something new. I absolutely encourage you guys to just mess around, just make an API gateway. It'll take you like 30 minutes or an hour. It'll change your life. I promise, you know? And even if it's not your cup of tea and you don't really see the benefit of it, then at least you tried it and you're more familiar with what it is when someone talks about it. And that's really valuable. So thank you, everybody.
I got a question real fast. I was trying
what's
to
up?
unmute and my daughter is okay. Shopify rate limits, is that something easy that you can do with GraphQL, or how advanced would that be with somebody branching out?
Yeah, so you're saying like, does GraphQL do rate limiting, right?
Well, I know GraphQL does rate limiting because Shopify does rate limiting and they use GraphQL API.
Okay.
And I was wanting to know if that is an advanced topic or something to go over, or could that easily be, you know what I mean, figured out through GraphQL's documentation.
Wait, I guess I'm still a little confused. So you're saying
I want to
how
learn
does
rate limiting.
Yeah, so
I can jump in here real quickly just because I know a little bit about Shopify. I think what Shopify does for their rate limiting is not related to GraphQL. I think actually they use Akamai, and they probably use like Cloudflare for that kind of stuff.
Okay.
Yeah.
That works for me because I was trying to figure it out.
Yeah, check out Cloudflare. They do rate limiting. That happens at like the request level.
Yes.
Yeah.
They give you points. So with Shopify, they give you 1,000 points, and depending on the query that you send is totaled in points. And if it costs too many points, they'll slow you down. They'll make you your next query not go through.
And they use GraphQL for that? That's pretty cool.
Yeah.
Well,
I don't know
Shopify
if they
used it.
I know with GraphQL, it can send back how much rate limit I still have. So then I can actually make functions to time out and wait until I gain more rate limit. They give you 100 points every second, but they only start with 1,000 points.
Wow.
They only start you with 1,000 points. And I have a Shopify store that I do freelance work with. They have over 8,000 items, like product items. So trying to just grab all the titles of that makes me rate limit. So then you have to use they call it a bulk query. And so then they handle all the computation of it and then they send it back to you. So
wow, well, that's really cool. Yeah, there's a lot of companies using really cool things with GraphQL. I know Amazon, they have some amazing implementations. We were talking about it earlier. Netflix is using it for their entire client, their whole front end process, their messaging, and it's changed their entire business model. They love it over there. So yeah, I mean, there's a lot of big companies, they're adopting it. If you know how to use it and you're okay taking that learning curve, it's amazing. It is really, really cool. All right. Thank you very much, everybody. Well, I will let you guys go. Have a nice night. Have a good weekend.
Thank you, everyone.
Try it out. Just go do like the tutorial on GraphQL.
All right. Thank
See
you
you
all
guys.
for coming out. Thank
Bye.
you.